Welcome everybody to the first Parabellyx webinar in May. Today we have a very exciting topic about the CISA software security development attestation, and we have a couple of people who I value as top experts in cybersecurity. Both of them have lots of experience. Uh, Adam Winston is joining us from ActZero, one of the top MDR companies in North America, and the one that's doing a lot of exciting research and trying to really use as much AI as possible in their MDR solution. And Adam is their CISA, and Eric Matthews from Parabellyx, who is our own CTO. So, gents, you've been around for a very long time, and you know that every time a new regulation comes out, it's exciting for us, but not so exciting for everyone who is trying to figure out the regulation and how to be compliant with the regulation. You probably remember the PCI DSS 1.0 coming out in 2003, and everybody is trying to figure out what to do about it. Should we, which kind of are we falling under the self-attestation? Do we need to do a proper third-party attestation with the QSA, so on and so forth? Back then, it wasn't that prescriptive, so people were also trying to figure out technical components. Now, fast forward more than 20 years, and we have tons of regulations, and new ones are coming out. Now, the one that we're going to talk about right now is the CISA Secure Software Development Attestation Form that CISA has released just less than 2 months ago, back in the middle of March. So one of the things that I want to ask first, and Eric, I'm going to throw it over to you. So can you please remind our audience here, what are the main drivers behind CISA Secure Software Development Attestation?
Well, a real challenge in the industry in software development was getting ahead of software vulnerabilities during the development lifecycle. One of the things we were seeing in the industry was organizations losing track of the main components of their security and applications, as well as the software supply chain. You saw vulnerabilities like Log4j hit the industry and catch a lot of companies off guard without being able. They were lacking the tools and the expertise to be able to identify risks and dependencies in their software and really nail down the various components of the software during their development effort. And that's fundamental to the requirements that we're seeing, is a mandate to really push the development teams to have a better handle on security throughout the life cycle of the development, and not just base that on sort of single point in time tests at the end of the life cycle.
Thanks, Eric. Adam, do you want to add anything?
Yeah, I mean, if you think about critical infrastructure in general, right, and most people who are probably watching this webinar maybe not totally familiar with who CISA is, they're an agency in the Department of Homeland Security that protects critical infrastructure, so water, finance, airlines, energy, that type of stuff, and of course HHS, Health and Human Services, which is a lot of the hospitals. And their mandate basically is to create policy, right? I've worked with a couple of people that have actually worked there that develop these policies, and people that work on the incident response side and the cybersecurity hygiene testing side. And recently, you look at this new form, and what they're trying to get their suppliers to do is to build a better, more robust form for checking the life cycle of software security testing that the suppliers have. Most people, if they've had to go and tell somebody how secure they are as a software supplier, or you as an agent, as a company, are doing vendor due diligence, you'll typically ask for something like a penetration test. And obviously, if you look at things like the supply chain, it's pretty complex, right? You look at the Change Healthcare attack very recently, and you look at CISA, the FBI, and HHS trying to coordinate threat intelligence and telling people what they should do about this type of attack because it's a pretty critical supplier, as we saw in the chain, you know, a lot of devastation from that cyber attack. They're trying to avoid that happening again. And if you listen to Chris Krebs, I was there in Las Vegas for the 25th anniversary of Black Hat. He was one of the keynote speakers. He was the former director of the agency under President Trump. And he was basically saying, if you make software, you're shipping targets. And if you host software, you are the target. And if you look at the way this is sort of, described, the form, right, we're going from the hosting, the infrastructure, and making sure that we have the right protection there. And we're trying to look at the software suppliers and the software, the people who make the software, and be a lot more prescriptive about what it is that they're doing in their process to secure the source code. And examples like Log4j, like Eric brings up, incredibly poignant because it was a tool that affected a lot of different suppliers, and trying to even understand as just a company how many different places you're using Log4j is expensive. So you're trying to shift, I think, the responsibility to the developers to get a little bit more involved and get a communications tool between the software supplier and the customer, and understanding exactly how secure their software development lifecycle is, instead of just getting a once-a-year pen test from them or a SOC 2 and assuming they're secure.
Amazing. Thanks, Adam. And I'm going to stay for a few more minutes on the subject because I think one of the questions that everybody's asking. So the Secure Software Development Station form itself, it's geared towards software development companies that work with government agencies. Basically, if government agency is using your software, whether they install it or use it as SaaS subscription, you will need to fill out this form. If you're under FedRAMP, you obviously will need to be audited on this. This is no longer self-attestation. This is going to be an audit. But in your opinion, how does this attestation form and the process is going to affect the broader technology community, the broader software development community, not just the organizations that are doing business right now with the US federal government?
So, I mean, CISA's mandate has been one of awareness, right? You wouldn't see the director show up to very, public events like Black Hat or the FBI going out and doing these tours if these agencies weren't attempting to make this a very broad-reaching piece of hygiene and policy that they could adopt themselves, right? The software supply chain is very big, right? When you think about even the Department of Defense, right? You kind of think of 5 big defense contractors, a massive, federal budget spend. And that's not who the defense industrial base is. It's 300,000 organizations that make up that supply chain that fill in all the parts to those critical areas of the government. Same thing here, right? If you think about health and human services as a critical infrastructure, and the hospitals and the hosting companies and the software companies like Change Healthcare, right, that are part of that ecosystem, CISA is obviously looking to build a mandate to protect the Department of Homeland, but you also have the agencies that supply to them that are going to have to sort of follow the same scrutiny. So I think that much like you see with FedRAMP, StateRAMP, the memorandum, if you haven't checked this out, maybe you're not a totally big government person and you don't know what a Federal Register is or what these memos are. They are having to get these different mandates out across an entire supply chain. And they're just now starting to develop things like StateRAMP or FedRAMP moderate equivalence or this attestation form to try to get the supply chain across the board to adopt this as a new standard. And I firmly believe that this is just an evolution of the kinds of questions you should be asking a software supplier. If I was to tell people as a CISO myself, and I run a virtual CISO program where I educate people on this all the time, what are the things you should be asking your software suppliers to make sure they're secure? You don't just collect a one point in time pen test, right? This is a very, is it baked into the entire software development lifecycle? Are you able to disclose vulnerabilities that you have? Are you able to disclose breaches that you have? It's very sound advice for people who are buying software to hold people to this standard. And CISA, I think, is just making the first move here. So I do feel like it will have broad implications, at least setting the tone for the suppliers within that supply chain that make software to try and adopt these practices and be able to communicate them to their customers.
And I think this will reflect a trickle down throughout the industry. Obviously, secure development lifecycle is something that we've been talking about for years, and it's part of any discussion that a developer has in a larger sense. At a conference, all developers talk about this. They know it's an issue. Development managers and product owners know that the secure development lifecycle and building security into the development lifecycle is a key part of their security, but the implementation and the uptake of that has been probably not ideal throughout all industries, not just in government regulated spaces. And I think the pressure we see coming from the CISA regulations will also trickle down and inform a lot of other companies who are developing software, even if they're not in that regulated space, to really get on their game, because I think there will be future regulations that span across industries beyond state RAMP, FedRAMP, and the CISA. We've heard whispers about White House directives for all software development, and those haven't come out yet, but I think they're in the near future.
Great. And that's really great insight. I think, as it propagates down the supply chain, what's going to happen is large organizations are going to start requiring their suppliers to do this, at least for the business critical parts of their software portfolio. And then it's really going to cascade down to smaller and smaller companies. Much like right now, even the smallest of the companies are being required to have a SOC 2. Same thing is going to happen. So now let's take a look a bit closer at the attestation form itself. And it really has, I would say, 3 separate components or requirements. One is obviously around the operational security and making sure that everything is configured properly and the monitoring. And then you have also another one around making sure so you understand what components you have as part of your software, basically your software supply chain and your software bill of materials. And the last one is really making sure that you do a proper and continuous application security testing, and you manage and you remediate all of the vulnerabilities that are critical and may interfere with either operations or the security of the application or the data. Now, the first part of it, this is something that is your bread and butter, Adam, right? It deals with securing and monitoring environments, including development environments, including developer-owned machines. So we all know that it is a significant challenge, and developers typically have requirements that are a bit more relaxed from a security perspective than everybody else in the organization. They need to do things, they need to test things that involve technology on their machines in the development environment. So that's why they typically have less restricted access. So what is the best approach, in your opinion, to secure the development environment without restricting the usability of that environment for developers?
Yeah, I mean, I'm a software developer. I can kind of empathize with them, right? I mean, ActZero as a managed detection and response company is first and foremost a software development company, right? We make the platform that we use in the service. On that front, of course, you have to engage with developers. I've done this as a VC, so for years, most developers see us as the brakes, right? They don't see us as something that's going to give them the free-flowing, open, easy connectivity and rights management that they're used to make any change they want, develop what they want, and move quickly, and be inspired to just set up new environments and tear them down and do all these other things that, like the CISA agency would say themselves, or their former director would say, shifts the target, right? Because you're making new targets for us constantly, and you're moving hosting as fast as possible to create new surface area for us in security. And obviously, they see it as a function of convenience. It's more convenient if they don't move quickly for security, and it's less convenient for them if they're completely clamped down. How I'd say, though, that this has sort of evolved to where we are today is if you look at a shared responsibility matrix for your cloud provider, for example, right? A lot of people who are in the software development business probably don't co-loco anymore. They're looking at things like Amazon or Microsoft or Google Cloud as their hosting provider, and that they've built these matrices that show you exactly what it is that they're doing for security, the networking and the hardware and the facilities and all that stuff, and the things that you still have to do from a detection and response perspective, including doing, if you have workloads in the cloud, you need to be deploying anti-malware up there, right? Just because they're, some fancy new version of Amazon Linux doesn't mean they don't require an EDR to detect and respond to threats. If you look at the cloud infrastructure itself, it's your responsibility to configure it securely, and it's also your responsibility to monitor it for malicious activity. Those two things are things that MDR does. And where we sort of meet developers is that they believe because they have the auditing on, the monitoring on, that's sufficient as collecting forensic evidence for when something happens. Or if they use a serverless app or a different version of an operating system, they're inherently secured from these types of MITRE attacks that face the infrastructure. And that's not true, right? So obviously in CISA's form, the first thing they're trying to get across to people is just because you're hosting something somewhere and they say they're doing a lot to secure it, that your job is done as a developer, as an infrastructure or site reliability engineer, as they're referred to there. You need to basically take the monitoring and the activity of the detection and response and make it part of your offering. And really, or the tools you're using. And really, that's my opinion on it, is that while we are increasingly going to see more work from this form and others focused on the software source code and the modules within it, which is really what this is all about, they're saying foundationally you still need to protect the infrastructure, and you can't avoid that. So MDR and a SOC and the concept of that is still going to be part of the mandate and one of the first things they talk about.
Great, thanks, Adam. And obviously, we work together on quite a few customers, and we have customers that are software development companies, and I can attest myself that they're quite happy with what ActZero does as an MDR provider in order not to restrict the developers and development environments in doing what they need to do while doing the full flow of monitoring of those environments and responding to any threats. So that's great. Eric, I am going to turn this over to you because the two other parts of the attestation, they deal with two separate aspects, right? They deal with the trusted source supply chains, where basically you have to identify, hey, we have third-party components, whether libraries, open source code, anything else that is, we're using that as part of our software. And we need to make sure that we know that this is part of our software, we have that software bill of materials, but also that we do the automated scanning and testing of the code itself and making sure that there are no defects that can create large and significant security vulnerabilities in that code. So how do you typically build a program to address both of those? And what, in your opinion, is the minimum set of tools that you need to employ to run this program?
Well, obviously, you explained the general mandate pretty well, in that there's both a software supply chain requirement as well as a code security requirement. And those are really two related but different things. Obviously, I think a lot of development managers and product owners will know that they come from different tools and different tool sets. So you have to combine the use case of a software composition analysis, software bill of materials, and the ability to not only identify vulnerabilities in your software supply chain, but also be able to identify libraries in your software supply chain. One of the big challenges in the supply chain when, for example, Log4j came out is developers simply knowing whether it's in their supply chain. And the reality is, even with some of the software composition analysis tooling, you don't necessarily always see the full supply chain, meaning, is it a second order included library? Is it included in one of the libraries that you've included, even if you're not including it directly? And that was a really common case with things like OpenSSH or things like Log4j. So a comprehensive software bill of materials is very useful for that, and one of the tools that we bring to customers when we bring a lifecycle platform. But then beyond that, there's also the code security aspect, and that is usually done with a software static analysis tool, and that's just a code security scanner. So that's a different but related component that's going to find issues, defects, and security oversights in the code and the area around the code infrastructure whenever we're developing software. The combination of the two really provides those key aspects for the CISA requirements, in combination with the infrastructure piece. I actually have a diagram here that we put together of what that looks like, a perspective of how those requirements are covered by our various organizations. Obviously, we've outlined the responsibilities of each of these pieces. The first section is about securing the development environment, and then the latter ones are about supply chains, internal code provenance, and automated tooling. And so, where does Parabellyx, where does ActZero fit in? Our CAST product is much more on the software development side, both the trusted supply chain as well as the code scanning. And then obviously Adam talked about their MDR solution with the capability of covering the infrastructure pieces, logging and monitoring, conditional access control, platform risks, and things like that.
Thanks, Eric. So that leads me to the next question, and I think both of you would contribute to this question greatly. So smaller organizations, smaller technology software development organizations, initially they would approach it as, let's try to build it ourselves. After all, we are a technology organization. It should be fairly easy for us to do. So when organizations try to build those capabilities themselves, try to do the security monitoring themselves, try to operate the software security testing tools themselves, what are the typical challenges that they would run into? And Eric, I would ask you this question first about the software development and software development security tools, and then I'm also going to ask Adam after that to comment on the security configuration and security monitoring stuff. So Eric, why don't you take this one away first?
Sure, yeah. One of the biggest challenges that organizations find when they enable tooling like this, well, first of all, there's the configuration and implementation of the tools, which isn't trivial. That's an area that organizations often can surmount, but it's an effort that they have to commit resources to that can be challenging. However, once those tools are turned on, the real challenges start, and often what we see is an organization will enable something like a SBOM tool or an SCA tool, a software composition analysis tool, and they'll find 600 or 800 vulnerabilities in the first few minutes of their engagement. So that is a real challenge for organizations to try to nail down what the what the remediation steps are. How do they prioritize those, and what does it look like when they're trying to outline their the risk of the various different pieces? And then beyond that, how do you communicate the decisions around risk to anybody that has an audit or a concern about that, whether it's management, whether it's an audit internally or an audit externally, or simply just better understanding your internal risk? That what we'll find in an SCA tool is out of the 600 or 800 vulnerabilities you see in the first few minutes, say 200 or 300, 400 of them are going to be high risk, and that's overwhelming and difficult to prioritize, and it's difficult to triage, and then it's difficult for developers to really come up with remediation after that. And the same is true for the static analysis tools, probably to a lesser degree. I don't think we usually see 600 or 800 vulnerabilities, but we see 30, 40, 50, and a lot of those are code changes that are required, and so we see the same deal with the severity of those issues being difficult to pin down, the remediation being difficult to pin down. So really, vulnerability overload or information overload is the common issue once organizations have enabled these. So, our tooling and our solution is trying to help nail that down. But that's really, that's how we approach it. We'll go into that a little bit more later. But Adam, I wanted to give you a chance to talk about the logging and monitoring side.
Sure. I mean, for starters, right, like if you're a startup, right, most software development companies, especially in the Valley, I mean, almost immediately, even before their ideas fully prototyped, are immediately raising capital, right? Either angel investors or some sort of venture capital. A lot of those VCs, if they're going to be taking, LP money, will have a mandate for managed detection and response. It's actually written into the venture capital papers as due diligence when you go to make an investment like this. And developers will always be coming at it from a different life cycle. Your Series A, you're just starting to build your software company. You've just scaffolded the tools. You're hiring the people. You're kind of working things out. You're obviously trying to be as capital efficient as possible. And when you don't have any customers or users of the system yet, it's easy to think that you probably don't need to secure anything because no one's really using it. So there's no customer data, intellectual property, it's probably not anything patentable yet, right? So where are we in terms of, unless you're in a regulated industry, where are we in terms of needing to buy this in the life cycle? Do we buy it now and bake the logging and monitoring in, or do we just do things like SCA, like Eric's talking about, CAST, and secure our source code? And then when we get customers, that's when we should be monitoring who's using the system, right? And the truth is that the system's live the whole time, right? That they realize this in the VC world where they mandate MDR as part of it as well. And so obviously this is one of the first things to do is to make sure that the minute you're using it, you are auditing the configuration and you are monitoring the usage of it. The last thing you want is to be controlled by a botnet or connected to in command and control scenarios where attackers have access to your environment. Because they will lay in wait until it's time to do something different, right? There's so many examples of even taking over your home routers to wait, for an opportunity to take down your developers who may be working from home, right? There's just a lot of energy that's being put in there. And I think that because a lot of people start saying we don't need to monitor until we have customers, or we don't need to monitor until somebody makes us, or we don't need to monitor because we don't have that sophisticated an environment yet, and it's expensive, especially in the small to medium, we'll probably have to just build that in kind of like hosting costs. I think this is, at this point in time, a cost of doing business. It's a cost of certainly raising capital if they have outside LPs. You're going to need to do this the second you turn on the service, right? And so it's very important to make sure that people understand they need to do that, and that service should scale as you grow, right? It should be not a massive upfront capital investment, right? Just like the cloud, it should be growing with you, right? So if you've got unit economics and you're not counting that in, it's a bad idea, just because you really don't have all the things inside the pie before you go to sell it, and then now you're potentially going to get a big surprise later when you say, oh, I didn't build it, I can't raise capital. I didn't build it, I don't qualify for insurance. I didn't build it, I have to reformat my app to allow these guys to monitor the identity in the logs, right?
Yeah, and another piece I think I'll mention is, we talk about unit cost and TCO, total cost of ownership, and the reality is when we talk about our CAST product, the solution to enable DevSecOps early in the process, organizations really actually save money in the development when they build that in early in the life cycle. The longer we wait to fix the security issues, if we wait until release day, we run a pen test on the day of release, a year down the road or 9 months down the road, and we find fundamental issues, which is really common when we haven't done any security, haven't built security into the life cycle. Those organizations are stuck with major costs, delays, and how that always works for developers and product owners when we get to release day and we say, hey, we have a release in 2 weeks, and then the security team comes in and says, no, you don't. You have 8 to 10 weeks of remediations to do. Your release date's pushed out. Everybody's pulling their hair out, and the reality is it ends up being significantly cheaper. And some research we've found says it's roughly 4 times cheaper to remediate those vulnerabilities in the process with a secure development lifecycle and the tooling, rather than to wait until release day to find out that you have these issues.
Yeah, one more thing, Alex, before we continue, just to add to Eric's point, because I think it's such an important one. They're trying to avoid you refactoring. Any software product manager that's heard the word refactoring before, you might as well hear disease outbreak, like at the CDC. It is a tremendously expensive endeavor to refactor something because you didn't consider an architecture, hardware, or some sort of other issue like security that you probably started building on this rented land you now have to remove out from underneath. Those architectural changes, those code refactoring, operations can be a lot. I've seen, unfortunately, customers, build their identity on top of an open source stack that was fundamentally flawed. Add a particular open source library inventory as a foundational component of their database, and then not realize the amount of tools that were incorporated in that are continuously going to pose a risk, or they didn't build a multi-tenancy or segmentation architecture, and they didn't try to solicit a government customer, and they say, where's my data and how's it shared with everybody else, and they go, oh, we didn't think about that, right? So not understanding not just the software source code vulnerabilities, the infrastructure monitoring vulnerabilities, understanding the architecture that you need to be putting forth in something like this, which really does require, I think, just a more mature look when we start to build it from scratch. And these frameworks are starting to show up not just in regulation, but in the resumes of people that are actually applying for CTO jobs and CISO jobs now. So you cannot be agnostic to how AI is going to be factored in, or how machine learning or web hosting in the cloud as AWS kind of thing. So it's very important, I think, that we stress refactoring's expense, and that if you fail to act preventatively, the cost of doing it retroactively is very expensive.
And I think that's one of the reasons, we include, it's kind of important that we include some architecture and some other components in the CAST product offering. So obviously we're building tools, we're deploying tools, we're managing tools, we're helping to control vulnerability overload, but also we're building in consulting time to help with that architecture, the plan, develop part, instead of just build, test, release. So we see a life cycle here. This is our Parabellyx application life cycle. It's not we didn't invent it, but we've aligned all of our products and our security offerings to this life cycle to really help nail all the way across the life cycle here. And so the CAST product offering is really from plan to deploy, and then we ActZero is looking at operate and monitor. Now the important thing to mention here is that when you're operating and monitoring your development environment, that comes before you start developing the code. So really, I mean, I could have put ActZero across the whole life cycle here as well, because they're securing the environments where the development begins. But in terms of a life cycle view, the focus is on that operational monitoring.
Great, and I just want to highlight something for the technical leaders that are watching this webinar. Something that Aram said about the greenfield applications turning brownfield. And this is very important, because the last thing you want as a technology leader is that a greenfield application turns brownfield on your watch. Now, what is something that really catalyzes the greenfield applications turning brownfield? It's really technical debt, right? Now, security is actually one of the most toxic technical debts that you can have. So when you start doing application security testing, or when you start securing your environment where you run applications, your ecosystems, which is your cloud, your containers, all of those things together, I mean, there are fundamental things that you need to prioritize and fix before they turn toxic, before they become that technical debt. And if you don't take time to fix those, then it's a tremendous opportunity lost. It's something that is going to stay with company for years, and it's something that in many cases are going to affect your decisions, and not in a positive way. So that's why it's important. It's not just about the attestation. Obviously, we're talking about that attestation, but one of the reasons why CISA is doing it, and one of the reasons why White House tries to shift the responsibility for security to software developers, is that basically avoiding those decisions, avoiding those bad security decisions that are going to haunt everyone, both organizations and their customers, for years. So that's great. Now, look, one of the things that our listeners start thinking about now, there are only 4 fundamental parts to that attestation form, but there are a lot of things that we need to think about. Now, really, between the dealing with operational security, security configuration of the environment, security monitoring, third-party software components, application security testing, and the management of all of the discovered vulnerabilities, like the organization, if they want to do it, they need quite a few unique skill sets to do this. So if you are the organization and you're thinking, I need those skill sets, what are those skill sets that they will need to acquire in order to create the program that will align with the CISA attestation? And Adam, I'll ask you to go first.
Yeah, look, I mean, the CISA running tests and doing hygiene and sharing intelligence and running incident response on behalf of those critical infrastructure teams almost in a way assumes that they are taking on that on their behalf, right? That there's no longer a responsibility on their agency side, whether that's HHS or the Department of Energy or something, to do those things. And obviously, I don't think anybody reasonable would say that that's that. It's not that you're going to now forego the skills because there's a third party here that's trying to do something on your behalf. The skills that I think you're going to have to spread out, of course, secure software development practices. You're going to become more literate, right? Rather than having the skills focus on intelligence gathering. Like if I asked our listeners right now, what's the log4j in the last 24 hours? What is the fastest moving software component vulnerability that's being exploited in the wild? Most of them would fail to come up with an answer because it's not their job to research that. If I said, what vulnerability in Chrome or your firewall or your cloud provider or what identity service vulnerability is currently being exploited by Alpha-V and Black Hat, the people that shut down Change Healthcare. Most people would, fail to come up with an answer, or they'd start Googling it and getting news from an agency that's really spreading threat intelligence about something that's happened maybe weeks or months ago, right? So they're obviously not going to be able to, if it's not their primary job, gain the skills, gain the resources, gain the relationships to be an intelligence gathering organization that can put those types of policies into practice on the infrastructure that will inform them that there's a code change to make. They will just become more literate when you have a tool like CAST or a team like yours finding these software library vulnerabilities, software code vulnerabilities. They will become more literate in the practice of software development and applying the principles, right? It'd be like, learning scripting and then object-oriented programming if you're a developer, and then saying, okay, now I'm more literate in how to use an object. Now I'm more literate in how to use regular expressions for input validation, or how to monitor my libraries, or what the log means when an IAM policy changes in S3, right? So while those are all three very technical examples, obviously for the longest time they've been unregulated, right? There's the lack of regulation in the software development industry. I don't think a whole bunch of places like Congress or the White House or anything wants to impose more regulation, slowing those companies down, because they're a darling of our economy, right? As these tech firms, right? So far be it for us to slow down anything from AI to software development to innovation, because we're leading the world in that, right? But at the same time, we have to find a way to dog food that cyber hygiene literacy into their software development practices. And so the skills they're going to learn by using tools and working with teams like this is to up their game, right? So they can still be specialists in large language models and software development and hosting and whatever, and Kubernetes and whatever it is that they're going to do. But then when we show up with the vulnerabilities and the best practices, they're going to start to say, oh, okay. And then for next time, I think it'll start to work its way, hopefully, into everything from education to best practices to resumes, is that literacy.
Mm-hmm. One of the things we see a shift in the industry, and this happened a decade ago or more for security monitoring. A couple decades ago, the hot thing in security monitoring was a SIM tool, and then you'd have to hire experts. And 12 or 15 years ago, security organizations were trying to sell you IBM QRadar for $1 million. And if you couldn't afford that, you're just out of luck. You just don't get security. And so the idea of an MDR came down as the response to that. How does somebody who's not a multinational, a Fortune 500, Fortune 1000, be able to nail the security at the cost of a per endpoint or a per seat? And so MDR was the solution to that. And that's been an evolution in the industry over the last 10 or 15 years, away from the big iron, $1 million up front and then and hiring a SOC team and having that expertise in house, which isn't really practical for most organizations. I mean, Chase Bank can do it fine, but the majority of organizations we're talking to aren't capable of that. And we're seeing the same shift in software security, and that's where our CAST platform is. It's really the MDR of software security, where we provide that model of a per seat or a per app expertise and tooling combined to be able to give an organization the straight prioritized list of vulnerabilities and steps that they have to take to better secure their organization without having to bring the expertise of DevSecOps and managing tools and bringing in multiples of usually six-figure costs of tools to be able to in-house all the software security. And that DevSecOps expertise is not trivial. I mean, it's just like hiring an operator for your SIM platform. It's a highly specific expertise that you don't need for anything else. And if it's just a portion of your organizational security, say an organization that develops one or two or three packages of software is in the position of really not being able to afford the DevSecOps expertise. They're not able to bring that in-house. And so either they're trying to find contractors and consultants, or they're trying to task, say, a lead architect who really should be doing other things in their business, to trying to learn the security platform and manage all that, or they're doing it poorly with an auditor and a security analyst who's also installing antivirus on the developers' laptops, and he's also trying to interpret DevSecOps and manage tools. And really, the goal here with both MDR from ActZero and our CAST platform is to keep the expertise without having to bring it in-house and in-source that expertise. So get the benefits without the cost.
And it's important to say, to Eric's point, like when you talk about the ideal customer for services like these, it's small people. Same sophistication of the attacker, same attacks hitting you. And I would encourage people, go to OpenAI's website, look at the careers page, or go to their LinkedIn and look at how many threat intelligence and red team people they have. Look at Meta, how many cybersecurity threat researchers, software source code development researchers they have working on just the intelligence problem. We're not talking about a small handful of people. We're talking about a global 11 office, tens of people working on just the R&D of what that software source code bug could look like, modeling it and applying it to a massive SOC. And you don't want to basically you don't want to stop the person in their garage from developing software that could change the world. That's where all these companies started, right? So it's not like we want to take these principles and not find a way to get it into these small to medium customers to make sure they're competitive. I don't want people to lose contracts with, agencies like HHS. I don't want people who are hosting their stuff in Texas to say StateRAMP 1,200 checks. I'm done. I can't compete against hosting person X or software supplier X. They've now got regulatory capture and they're beating me to win these deals. That's not what we want. I think we are on this call to make sure those small to medium customers are protected and just as good at their security practices as the big guys, so that they can still get those contracts, they can still run their businesses and not have to fold or drop these contracts.
Yeah,
absolutely. And I'm actually going to ask a bit of a controversial question now. And the reason for this, we've heard that, look, you need a lot of different experts. You need the security experts. We're talking about not just analysts that are going to monitor and look at the issues, but we also need the cloud security engineers. We may need container security engineers. And on the other hand, we need security people that know how to code, or coding people that know security, in essence, to understand what's going on and kind of triage the vulnerabilities or security defects that scanners that may be quite noisy are finding in the code and in third-party components, and understand what needs to be fixed first, because there's just too much to fix everything. Now, but for everybody who thinks, well, how do I start? Like, where do I even begin with that? The first fundamental question is, who is going to own this program, right? Is it the program that should be owned by a development team, ultimately reporting to vice president of engineering or CTO, or is this something that needs to run under a security team and ultimately report to CISA, or if they don't have a CISA, someone like a chief compliance officer, or maybe even the CEO of the company. So Adam, because you're running the vCISA program, I'm going to ask you first, where does it fall under?
Yeah, so I think the reason, despite me trying to distribute the workload in my career to new faces, why I keep ending up in the position of CISO is that there's a selling process that goes into making sure if you're not getting direction from your superior, you're getting logic from your peers, right? And when you think about a typical software organization, site reliability owns, usually the hosting facility, the infrastructure, software development, engineering, maybe the CTO is sort of running their software development teams, and then you have support jobs across either side, right? Sales engineering, obviously the back-end admin staff that are looking at things like legal, finance, the senior management, probably hitting board meetings and trying to think about company growth. And so, when it's not your specialization, it's hard to be emphatic about a mandate. It's hard for me, like if I'm not in the CDC, it's hard for me to argue about the use of, one vaccine or another. If I'm, in an executive branch, yes, I probably control the purse of the company and everybody should listen to the CEO, but they're going to listen to their direct managers the most, right? In security awareness programs, when people don't follow, the training or they fail the phishing test, you tell their manager, right? So obviously in the key components, right, software development, site reliability, the engineers, the CTOs, and the directors, VPs of site reliability, those are the places you're going to have to get the inception moment. You're going to have to get that belief system going, and those two teams are under a lot of pressure to keep things up and running or to get things out the door very quickly. And so you usually have, unfortunately, only in larger organizations, a CISO that shows up to be the peer communicator to these two, to sell the problem of speed, efficiency, prioritization of cybersecurity problems that are adding to their existing agile pipelines or never-ending project management and enablement tools, right? So you usually have a vCISO come into those organizations because they don't have the knowledge, the intelligence, the expertise to come in and sell the economics of what's going on, the downstream or residual risk that's going on, the actual problem. I famously had a conversation a week ago with a healthcare hosting company that was unaware of. They had a previous MDR who was telling them, "Oh, this isn't a problem. This thing that their AV found." And I was like, well, they failed to articulate what the risk actually is of that application and what the attacker can do with it. So you have very little understanding actually of what it is. They just say high severity 8, this little utility is a problem. So says, Trend Micro or whoever. And that's obviously not enough of a sell to get them to make the move. And so unfortunately, I feel like even if you have security buy-in at the top, even if you have these very well-meaning management teams in engineering and site reliability, or even if you have a very deep mandate from legal or finance to follow a certain compliance practice, you're still going to need an intelligent, real-world communicator that's going to sell the problem between the two units, which unfortunately creates job security for the vCISO and the CISO in the small business. But of course, I'm very biased because that's the world I live in, where I walk into these environments and I have to sell. Maybe the IT admin or director really knows the problem, but nobody else is listening to them, and so you have to sell those two leaders, usually the leadership in the engineering and leadership in site reliability.
Yeah, one of the key things that we do in CAST is offer different deliverables to different parts of the organization. So fundamentally, we recognize that the DevSecOps team or team member, part of their job is to filter the information for the appropriate audience, and so that's a key part of, I think, both of our service offerings. What we present to developers is very different than what we're presenting to say leadership or senior leadership or auditors and then that's very different than what we might present to a third party or a customer. So the idea here is in our CAS solution is to be able to present developers with just what they need, which is the 10 most critical vulnerabilities they have to fix for this sprint. On the other hand, leadership or management may be looking for trending. So we're giving period, like month over month trending vulnerability scorecards on how organization is doing according to like an OWASP classification scorecard. And then we can provide an attestation, which would be maybe for a third party or an insurance company or a customer to say this organization is doing an adequate job at DevSecOps, and we can attest to that as a DevSecOps organization.
One of the things I'd add to what Eric's saying, because I actually, we've been checking each other's work now for I don't even know how many years. I've been a consumer of the Parabellyx reports, penetration tests across our customer base, of course, for the ones that use you and elsewhere. But when I look at the way that I've structured the information, it's very important to see not just who you communicate to, but the method by which you communicate with them. And one of the things I've tried to become an advocate for is things like a daily cybersecurity report or a briefing, right? Because there's just so many things that are going to come out of the intelligence, they're going to come out of the penetration test, they're going to come out of the continuous assessment you maybe have from vulnerability management or other projects, those other risks. And it's important to kind of consolidate that into a reminder that this is a continuous problem. It is going to be an unbroken daily activity for the rest of our existence until they build a better immune system for the internet. I think that if you have a way to formulate your ideas into a brief or to consolidate the information you're getting from firms like ours into a brief and then just use that as a way to report to each other, either maybe in stand-up or in another forum, you don't have so much time between things like a board meeting or a monthly security review or an annual general meeting where maybe they give you the floor for 2 minutes to say what cybersecurity problems are we going to see or come back with. That's a fun exercise for the company to be kind of looking at things forward directionally, but a daily brief is really what you're after. So if you were to build a daily brief right now today for your company around cybersecurity threats and the weaknesses, the vulnerabilities of it, what would you put in the brief? And if you're finding yourself looking at a blank page, but sure there's something bad out there, it's very obvious what these services will do for you, right? Is get you in the know.
Thanks. And I'm going to ask one last question myself, and we're going to take just one question from the audience just because we are at the top of the hour. But the last question that I want to ask is, look, we've talked about so much, we've covered lots of topics right now. So if we have listeners here that are really smaller organizations, they would say, great, but where would I start other than just picking up the phone and calling Adam or calling Eric, which is not necessarily a bad thing, but really, where would the organization start building that program, preparing for that attestation, especially if they're working with the government or want to work with the government in the near future? Where would they start?
Eric, do you want me to go first?
Yeah, go ahead.
Yeah, no, I would say you would take the form, you would fill it out for yourself and look at it, right? Like it's a very simple set of questions, right? They of course have links to other NIST documentation that will probably get into control codes and things that you're probably not used to seeing if you've never seen a NIST library document before. But the idea is that they're going to be very prescriptive, crawl, walk, run, chronologically, go through this, answer the questions, figure out where you are. Even if you don't have to submit something back to CISA, right, because you're not part of a software supplier to their agencies or anybody within their mandate, fill it out for yourself. If you're listening to this or you've got some concerns, if you make software, fill this out for yourself. What it really does is just give you, at least notionally, if there was a best practice around the process of finding vulnerabilities in your source code and detecting and responding to cyber threats, where you are, right? And give yourself a bit of a letter grade. This is what I believe is the new minimum, right? Unfortunately, I do not think this is a aspirational, high maturity, new standard that's going to protect the most critical defense contractors in the world. I think there are other.
No, they're already doing it.
They're already doing it. I think this is for the software developer that's got their little cloud and engine going and they make and host something. Well, take a look, right? This is the baseline for you.
Yeah, and we see large organizations have been doing this for years. And again, it's the same deal with like MDR. Is ActZero came on the scene, was it been like 8 or 10 years now, right? And but before that, it was go spend $850,000 on QRadar. I hope you have the expertise in house, right? And so that those organizations, the power grid and the major banks have been doing that since the first SIMs came out and the first DevSecOps tools, the first SAST scanners, and these are 20 something years ago. But the smaller organizations, those ones that don't have the budget for an entire team to manage those tools, are the ones that are really, number one, seeing the benefit of the offerings that are out there today, but also number two, feeling the pressure to do that, because security isn't an option anymore. I mean, it's just not. It's business ending in a lot of cases to be breached, and that's not a risk that a lot of CEOs are going to be tolerant of. So when we look at that, I would say the first step is to know what you know. Get an understanding of your inventory. When we talk about the old security mandates from years ago, talking about, how do I secure Windows 98? The first step was get an inventory of your assets, and that's true today. Assets are different. They're you have an AKS cluster, it's Kubernetes in Azure. It's different. It's not Windows 98 on a network with a closet full of switches. It's data security in Azure and AWS and Kubernetes and software code assets. And so getting an understanding of what you have first, like what do you have, what do you own, what do you run, what do you operate, and where's your data going, will really underscore, ask the question for each one of those assets is, how do I secure this asset? And assets include code, and it includes databases, it includes DevOps pipelines, automation tools, and really nailing down those things is where you start, and then start going down the road of how well do I understand these controls, how well do I understand the components and the risks associated with them, and the likelihood of exploitation, and that'll help underscore, I think, where the next steps are, because the answer for most small organizations, when there's a product owner, a CTO who's in charge of a diverse set of infrastructure like this, is I really well understand these two components, but these other ones, not quite sure how to secure them. And even if you feel like you don't have time, because there's a lot going on. So there's an understanding of that, of what's out there before you take the first steps, and then like Adam said, try and fill out the CISA questionnaire and see where you might fall, and then decide from there.
Just to echo that point, because I do this I can't even tell you how many times I do this, maybe once a week. I produce a sheet that says, here is the data you collect with what application, how is it stored, how is it deleted, who are the teams that use it, and then what are the links to things like third-party documentation, patches, et cetera. So even just from a vendor perspective, you understand all the software you're using. So even if you don't make software, you're probably using it, right? So, ship the target. Okay, you got to fill out the questionnaire. But like Eric says, even within that questionnaire, it's not complete. If you're a software developer, you probably have a bunch of libraries, a bunch of tools you use. You need to make an inventory of that, even if it is more complicated than how many Windows 98 assets you have. Similarly, if you have a bunch of different vendors, it'd probably be very important for anybody to at least get that as the starting position. If you don't even know what you have, how are you able to tell me how secure it is, right? So exactly, I think those two events go hand in hand. If you develop software, just fill out the CISA form, figure out where you are as a maturity of an organization at the base, and then getting an inventory of your software apps and the data collected by them starts to get you into the game of, okay, now what are we going to do with this problem?
Amazing. Thanks, Adam and Eric. Now, the last question coming from the audience, and I think it's actually a very relevant question. This is something that we should probably ask ourselves. So we've mentioned penetration testing a couple of times, and we didn't mention it in a positive light in this particular conversation. It's like penetration testing is really something that we used to do in the past, but the question is it still relevant? Right? I mean, if you look at the attestation form doesn't talk about penetration testing. They're talking about the vulnerability disclosure program, but not penetration testing. So is penetration testing still relevant? And where does it fit in?
Yeah, for many areas, penetration testing is still very relevant. I see application penetration testing as a key component to a DevSecOps lifecycle. I don't see deploying DevSecOps and not having a comprehensive checkpoint at some point during the QA process. What you get out of DevSecOps and the tooling is really to minimize or eliminate the vulnerabilities that are found in a pen test. But even in the most robust static code analysis, there can still be vulnerabilities that are released as a result of either business logic decisions that aren't appropriate or oversights in different components, architectural components, or even interplay between things. And I've seen it go as far as as part of a research organization a few years ago looking at software security vulnerabilities, and a bunch of antivirus tools in their scanning engines had buffer overflows. And all of those tools were subject to static code analysis, but the buffer overflows came out during the compilation. Now, that's an obscure reference, but the point is that checkpoints at multiple places in the typical concept of defense in depth is really important. And having a singular tool and saying we're good now, we've got it secured, never is going to be the best practice. And so the best practice is really to layer your tools in a defense in depth, security onion approach, and to make sure that each step gives you a little bit more assurance, and no step is ever going to find every vulnerability. When you build a DevSecOps program, you do pen testing, you do infrastructure analysis, you put an MDR, you have infrastructure pen testing, and in addition to the application pen testing, you're still going to probably have rarely, but occasionally have vulnerabilities that sneak through all of that. So it's best to layer those and make sure that there's a clear defense in depth approach.
Yeah, I mean, one of the things when I was testing the Anthropic Claude 3, the AI models from them, one of the things, their large language model, I would always try to give it a very ambiguous question and see what it came up with. And one of the questions I asked was, what's a penetration test? And the reason I ask it is there's so many different varieties that I've seen over the years handed to me as a CISO from a third party. And they said that we did a penetration test, here it is. And it was a CIS controls audit, or it was an external vulnerability scan, or it was Metasploit running on a server internally, or it was somebody running in as a social engineer is dressed as a cleaning person. And I looked at it and I go, yeah, all of those are examples of potentially entering an environment, either physically or virtually, from an outside party and gaining access, which I guess was the method around the word penetration. But that word has unfortunately just not been able to capture a good framework for doing an assessment, right? If you look at other frameworks that I think are more comprehensive, like a MITRE or libraries like NIST or NIST CSF, they're very grounded in the idea that there's a scope to what they're looking at, right? They're going to audit certain aspects of your environment. They're going to look at certain practices and procedures. And then even in things like MITRE, they're going to give you examples of not just how it's exploited, but how you can detect it, right? So from the word penetration test, I think you can do such a small component of it and say you did it, or you can do an incredibly exhaustive exam and still not get through all of it, right? And I think that as a community, we've probably just got hung up on this word because we used to have, port 25 and port 443 or 80 open outbound, and we really just wanted to make sure no one could get into our little enclave of our office, which was desktops and switches and everything. And that's not the world we live in anymore. If I think about a penetration test today, if you've got work from home, if you've got the cloud, if you've got third-party software apps, if you've got, a Coloco, a whole bunch of other software to suppliers, the ubiquity of your access and the idea of penetration in any one of those environments, because you have this massive surface now, is almost not even worth trying to discuss, right? It's too boil the ocean. So we end up with, back to the CISA documentation, ways to test individual suppliers. We get tested from inside and outside the network against MITRE attack, enterprise infrastructure cybersecurity attacks, right? Those are the ones you should do to test us. If you're making a software development, if you're building a software application, you want Eric in there, right? You want a person that's going to try to test your source code, static analysis, or other ways to pen test your application to see where there's flaws in the application, right? That maybe your MDR EDR isn't logging your SQL logs to tell you if the application is being abused, right? That's the idea, right? Because they are different environments. So I believe that we probably need, in penetration testing, I had somebody ask me this at a conference once, how do you think penetration testing needs to evolve to start being more relevant to people when we're still running, Metasploit externally as a scan? And I said, well, you're going to have to start compartmentalizing. Each one of these places is a surface. Each one of these places is it requires its own framework for cyber attack. And if you go to MITRE, there's different frameworks for cloud, Linux, Windows, IoT, the AI, right? If you're purple testing or pen testing, red teaming AI, it's a whole different set of tests, right? You're talking about, prompt hacking and all this other stuff that doesn't exist, that you're not going to get any value out of if you test your own app or your infrastructure on. So I think that, the word penetration testing is nice to say, oh, you're going to examine things, and there's many ways to do that. Great. It's a security assessment, I guess, is as simple an answer you'd give it if I was the AI answering the question. And then I'd say, well, unfortunately, there's very many different ways to categorize this in terms of the type of test, where you're testing, how you're testing, blind, not blind, purple team, red team, what are we doing is it a breach simulation? There's just so many different versions of this that I've seen come across the desk. So I think we mention it because we've seen so many different varieties of it. We almost roll our eyes as practitioners to say, okay, pen test, what do you mean? But I think the community, especially the people who are buying these things, need to get more savvy about what these tests can be and should be, and probably, again, seek advice from a practitioner about what you're actually going to get. Because if all you're doing is asking the vendor which one you should run, guess what? The one you're willing to buy, right? That's the answer.
And what we see in the industry, and we still do a lot of penetration testing, is I want to. That's the first question we ask is what's your attack surface? And so this isn't the right talk to talk about this, but we're introducing a new product that's an attack surface management, and the idea there is to really identify the bulk of the attack surface, and that can range from ports and services like the old-fashioned Nmap stuff. It's also applications, but it's also shifted to public data risks, and when we look at breaches in the wild and where they're coming from, what's the source of breaches, it's shifted from network focused attacks, port 25, port 21, to application attacks and public data attacks. And those are the two biggest causes of breaches. Is either I'm targeting the application, I'm dumping out the user's credentials, and whether it's Twitter or Ashley Madison was a famous one, or it's public data attacks, and those are probably the most common, which is, have I found breach credentials? Did I gather a list of users from a forum or something like that, and then use those to target an organization's legitimate access methods, whether it's VPNs or webmail or however that is. So understanding the attack surface is the first step toward answering the question of what should I be testing. I still think testing is valid, but it's important to recognize, like you said, that there's a lot of different attack surfaces of different shapes and different provenance, because they're different. There is your cloud environments, there's your applications. You might even still have on-prem infrastructure. We see that with legacy, we see that with manufacturing, and we may even be OT environments like manufacturing. I know we work with some of those too. So that's an enormous question, but the simple answer is yes. Continue to do attack simulations, because it's relevant to a defense in depth approach. Just make sure that they're targeted at the appropriate environments, and don't accept a external network infrastructure test, which is, again, we still do them, but their relative value is much lower than they were 20 years ago, when we used to breach companies, email and user credentials from the internet relatively regularly. Nowadays, it doesn't happen, not really, unless somebody's made a major mistake. And so instead, we look at attack surface mapping and identification. We look at applications. We look at that public data, and then we go from there.
Thanks, Adam. Thanks, Eric. One thing that I'm going to add from myself is one of the ways to look at the penetration testing is really it's your safety net. It used to be that penetration testing was that catch-all, we're going to test everything and we're going to find it through the penetration testing. Not anymore, because systems and the entire attack surface just became too complex. Even for the smaller companies that do applications, that have SaaS applications, it's just too complex. So penetration test needs to be focused, it needs to have purpose, and it has to shift from the network more towards the application itself. Just like if you look at the penetration testing frameworks, and yes, we still have the infrastructure penetration testing frameworks, but they generally haven't been updated since 2010, 2015. Now, for application, obviously, there is OWASP, who does the OWASP ASVS application security validation standard, which is amazing standard. They're doing great work maintaining it, but this is application specific. So that's why you really need to focus on the specific purpose, and you need to treat it as a safety net. Can I catch something that I haven't caught during my other cycle of testing? And this is what you need to use penetration testing for. And obviously, some of the regulations, such as SOC 2, still require you to do the penetration test. So don't forget about that. Amazing. Adam, Eric, thank you very much. This was an extremely meaningful conversation, and I'm sure our audience loved this. Thank you very much to everyone for attending, and we're looking forward to seeing you with for our next webinars. And have a great day. Thank you.
Thank you.
Talk to you later. Bye, guys.